So first we have here is include link queue.h, in which we can use the methods add queue and delete queue that acts as push and pop respectively in this program. So first we declare a variable of x and y and store a value of 4 and 5. Then we use the method addQx that stores a value in the list. We use the formula here, qrear plus 1 modulo max queue size is equal to 0, then count plus plus. The next line also uses the same method but stores a different value instead. So we do it again, qrear plus 1 modulo max queue size is equal to 1. Then we set the value of queue front to x, which also has the same value since our queue front is also 4, so nothing changes here. So on the next line we will use the method delete queue. In this method we don't actually delete the first element, but instead we assign the next element as the queue front. So we use the formula here, queue front plus 1 modulo max queue size is equal to 1. Then count minus minus 0. And on the next line, in the next 4 lines, we'll just be using add queues here and apply the formula qrear plus 1 modulo max queue size is equal to 2. Then count plus plus. So we use add queue again, the next line, qrear plus 1. Oh, I forgot to store the values. Add queue is 4, 5, delete queue, add queue x plus 5 is equal to 9, count plus plus. So we use add queue again, qrear plus 1 modulo max queue size is equal to 3. So we store a value of 16 in index 3 of the list, then count plus plus 16, 2. Add queue again, qrear plus 1 modulo max queue size is equal to 4. Then we store x, which has a value of 4 in index 4, then count plus plus 3. Then lastly we use add queue again, qrear plus 1 modulo max queue size is equal to 5. Then we store x, which has a value of 4 in index 4, then count plus plus 3. Then lastly we use add queue again, qrear plus 1 modulo max queue size is equal to 5. Then we store x, which has a value of 4 in index 4, then count plus plus 3. Then lastly we use add queue again, qrear plus 1 modulo max queue size is equal to 5. 5. Then we store a value of y minus 3, which is 2, in our new courier. Then count plus plus 4. After that, an output of q element is given followed by a while statement that states that if q is not empty, then you output the value of q front, which is 5. After that, it will use the method delete q that adjusts the q front to the next element. Q front plus 1 modulo max q size is equal to 2. Then we do it again until the list is empty. So we have here in index 2 of the list is a value of 9. Then again q front mod plus 1 modulo max q size is equal to 3. Oh, forgot count minus 3 is equal to max q. Our new max q front is 3. The stored value in index 3 of the list is 16. Then q front plus 1 modulo max q size is equal to 4. Equal to 4. Then count minus 2. Equal to 4. Index 4 of the list has a value of 4. Then we apply the method again. Q front plus 1 modulo max q size is equal to 5. And count minus 1. Minus. So we have here in index 5 of the list is a value of 2. After that, we apply the method again, so it will satisfy the loop since it won't have any element to read. Okay, so q front plus 1 modulo max q size is 6. And count minus is 0. Then C out end line return 0. That's it.